So problem number 13 on the worksheet reads, movie star and martial arts guru Sung Kim has the ability to walk on walls in certain situations. Suppose during one movie scene, Sung, who has a mass of 75 kilograms, needs to walk on the walls halfway around a round room. The room has a radius of 4.5 meters. If the coefficient of friction between his shoes and the wall is 0.8, with what speed must he traverse the wall? The first step is to draw diagrams. So as you can see, I have two top diagrams. One is from the top view of him walking around the walls, or running around the walls. And the other is going to be kind of a side view, but in more of a 3D sense. So we know that in the top view, the radius is 4.5 meters, that mu is 0.8 between his shoes and the wall, and then his mass is 75 kilograms. So then the reason why I drew the box is to represent Sung Kim to make it easier to draw the free body diagram. And in the free body diagram, the force of friction and force of gravity are going to be on the y-plane because if you think about it, his shoes have to be touching the wall. So his arm, if you were to stand him straight up, his arm would not be touching the wall. Instead, his feet are the part that are touching it. So you have to think of him as if he's laying down on the x-axis. So the force of friction is going to be going up because it's going to be opposing him, and then the force of gravity is going to be going down still because it always goes down. And then the normal force, because his feet are against the wall, the normal force is coming up from the wall perpendicular to his body and going out into the actual circle, into the center of the room, essentially. And then you know that your force of friction is positive, your force of gravity is negative, and then your normal force is positive as well. Then it comes time for the equations. So you know that on your y-axis, you're going to have the force of friction and then the force of gravity. And as we had said before, the force of friction is going to be positive and the force of gravity is going to be negative. So on the y-axis, you're essentially, if you're plugging it into Newton's second law, you have f of f minus f of g equals may. And we know that there's no acceleration up or down, so there's no y acceleration. So that's going to cause the equation to equal 0, because m times 0 is going to be 0. So then you can have so then you find that force of friction is equal to the force of gravity, and the force of gravity is equal to m times g, which is mass times gravity. And then we also know what we can do is we also know that force of friction is equal to mu times the normal force. So then if you set that equal to m of g and you solve for f of n, which will be useful later, you'll find that f of n is equal to mg over mu. And then on the x-axis, if you're using Newton's second law once again, the only force on the x-axis is the normal force. So then what you're going to do is you're going to plug that into the equation. You have f of n equals max. And then we know that acceleration in terms of in circular motion is equal to v squared over r. So what we're going to do is we're going to substitute v squared over r for the a, and then you have f of n equals m times v squared over r. And then you already solved for what f of n is equal to. So what you're going to do is you're going to plug it into the equation. So you have m of g over mu is equal to m times v squared over r. And that's your equation, and you already know all of the variables. So then you can find it later on. So now we know all of our variables, because we know that mass is equal to 75 kilograms, mu is equal to 0.8, and r is equal to 0.5 meters. So now we just have to find what v, my apologies, it's supposed to be v, not v squared. So when you have your equation, which is mg over mu equals m times v squared over r, you're going to go and plug everything in. So you have 75, which is your mass, times 9.8, which is gravity, over your mu of 0.8 equals 75 times v squared over 4.5, which is your radius. And then when you go through the steps of algebra, which I have listed here, you're going to end up with your velocity being 7.42 meters per second. And if you plug it all back in, it should work perfectly fine. And there you go, you answered your question.